We're going to let D be an 8-bit number and consider the operation here. We're told, or asked, how does this operation affect D? Well, with D, it's a hexadecimal, so we're going to be dealing with hexadecimals. When we deal with hexadecimals, let's write out that our A is equal to 10, our B is equal to 11, C is equal to 12, and that means our D is equal to 13. There's more, but we're not going to be touching those right now. Looking at D as 13, we have 2 cubed, 2 squared, 2 first, 2 0. Well, D being 13, we know that we have to have an 8 here, so that's 1. 2 to the 4, or 2 to the squared is 4, so we'll add these together. This is 0, and that's 1. And that's how we would have our D. So writing this out, we're not going to look at the other bits. We're just going to write them as D7, D6, D5, and D4. And then we have D3, D2, D1, and D0. Next we have our 0x20. So we can look at this. Our 2 is just going to be 0, 0, 1, 0, 0, 0, 1, 0, and we can look at this for any reference that we need. And 0 is just going to be 0, 0, 0, 0. So we want to OR these together and ask, how does the operation affect D? Well, for this, we're just looking at the change for our D. Now, since it's an OR, none of this will be changing. So we're just going to have 1, 1, 0, 1. Since it's an OR, because these are zeros, these aren't going to change. So it's still going to be D7, D6, and D4. Now, notice how this is a 1. Because this is a 1, this is going to be changing. And since it's a 1, it's going to be setting because it's an OR. So this is going to be 1. It's different from our D5. So we can get rid of clearing. And we're going to be setting not bit 6, but bit 5. So the answer for this would be setting bit 5 of D. And that's how we would go about solving for this and anything like it.